Hot take. The fastest vector search in your stack might be the one quietly making your answers worse.
That is the core tension. In RAG, retrieval decides what the model gets to know, and tiny misses at search time can turn into very visible mistakes in the final answer.
So this is not just a database detail. It is a power move. Retrieval picks the evidence, and the model can only reason over what it sees.
Exactly. And the fight is usually exact search versus approximate search. Not because one is morally better, but because production systems have to balance quality, speed, and cost.
Start basic. What does exact search actually mean in a vector database?
Exact search means you compare the query vector against every candidate vector that could match, compute the real similarity score, then return the true top results for that search space. No shortcuts. If the best document is there, exact search will find it.
So, exact search is brute force with manners.
Pretty much. If you have 50,000 chunks, that can be fine. If you have 50 million, and users expect low latency, brute force starts to feel expensive very quickly.
Give me a concrete RAG example where this matters.
Imagine an internal support bot over product docs, release notes, and incident write-ups. A customer asks, "Why did API key rotation fail after the last upgrade?" The exact answer lives in one postmortem chunk among millions. Exact search checks them all. Approximate search tries to get you close fast, but it can miss that one chunk.
And if it misses, the model still answers. That is the dangerous part.
Right. The user does not see retrieval quality, they see a confident answer. So a small recall loss in search can become a large trust loss in the product.
Then why does approximate search win so often in practice? If exact is correct, why not just pay for correctness?
Because production is not a purity test, approximate search uses indexing structures and heuristics to avoid scanning everything. That cuts latency and compute dramatically, especially at scale. In many systems, that difference is the gap between usable and unusable.
So approximate search is basically saying, I might miss a few top neighbors, but I can answer before the user gets annoyed.
Yes, the trade-off is speed versus recall. Speed is how fast you return results. Recall is how often the important relevant items are actually in those results. Approximate search usually improves speed by accepting some recall loss.
That sounds abstract. Make the trade-off feel real.
Say your assistant retrieves top 5 chunks. With exact search, maybe the crucial policy document appears in position 3. With approximate search, that document might be missed, and a near but weaker chunk gets pulled instead. The answer is still fluent. It is just grounded in thinner evidence.
So, the loser is not just accuracy. The loser is the team that thinks retrieval is good enough because the demos still look polished.
That is a real strategic risk. Approximate search can make a system feel great in a benchmarked happy path, while quietly failing on edge cases that matter most. Rare errors, legal exceptions, old migrations, one weird note from 6 months ago.
And those are exactly the cases where people need RAG, because the model's generic knowledge is weakest there.
Correct. RAG earns its keep on specificity. If retrieval blurs the tail of the knowledge base, your product can become excellent at obvious questions and unreliable when the stakes rise.
So, how should a programmer think about this without getting lost in tuning folklore?
Start with the job to be done. If your corpus is small or heavily filtered first, exact search may be simple and totally viable. If your corpus is huge, latency is tight, and traffic is real, approximate search is often the practical default. Then you engineer around its weaknesses.
What does engineer around it mean in plain English?
Use metadata filters to shrink the search space. Retrieve more candidates than you need. Re-rank the top set with a stronger model. Reserve exact search for high-stakes flows, or as a second pass when confidence is low.
Give me one more scenario.
Think about a medical policy assistant inside a hospital. A nurse asks whether a medication exception applies to a pediatric patient with renal impairment. If approximate search skips the exception memo and returns the general dosing policy, the answer may sound coherent and still be operationally wrong. In that case, A slower pipeline with higher recall can be the safer product choice.
So the winning design is not always fastest retrieval. It is retrieval matched to consequence.
Exactly. Exact search buys certainty about the nearest neighbors. Approximate search buys speed and scale. Good RAG teams do not argue in the abstract. They decide where misses are acceptable, where they are dangerous, and build the retrieval stack accordingly.
That reframes the whole decision. This is not search theory. It is product strategy hiding inside an index.
And that is the line to remember. In RAG, retrieval is not just about finding similar vectors. It is about deciding which truths your model gets to speak from.